When we're classifying a triangle, we can classify them by their sides or by their numbers of angles. If none of the sides are the same, we classify that triangle as a scalene triangle. If two of the sides are the same, or if two of the angles are the same, we call that an isosceles triangle. And if all three sides or all three angles are the same, then we refer to it as an equilateral triangle. For triangle A, if we compare the sides of the triangle, we have a 7, a 10, and a 4. None of those sides are the same, so we call this a scalene triangle. For triangle B, it's worth noting that anytime we have this square on the corner of a triangle or on the corner of any figure, that angle represents 90 degrees. With that in mind, if we compare the angles of this triangle, we notice that we have two 45-degree angles. So two of those sides or two of those angles are the same. That means that this triangle is a isosceles triangle. For triangle C, we compare the sides. Two of those sides are exactly the same. That means we have an isosceles triangle. Now triangle D can be a little tricky because if we look at the angles, all of the angles are the same. In other words, three of those angles are the same. So we consider it to be equilateral. The thing is though, a triangle can be classified into different names. So it's not just equilateral triangle, but if we take any of these two angles, we'll notice that they're obviously the same. So we consider this to also be an isosceles triangle, just for the fact that they have a pair of angles that are exactly the same. This is the type of problem that students most often miss, so hopefully this explanation makes sense. If we look at the sides for triangle A, we'll notice that they're all different. Anytime none of the sides are the same, we call that a scalene triangle. For triangle B, we have a 30-degree angle, a 90-degree angle, and a 60-degree angle. None of those sides are the same, or none of those angles are the same, I should say. So again, we label this as a scalene triangle. Triangle C has two angles that are exactly the same. We call that an isosceles triangle. And triangle D, if we look at all of these three sides are the same. So we do consider that to be equilateral, but because a pair of them, at least two of those sides are the same, we also call this an isosceles triangle. For this last example, we have triangle A, which has two angles that are exactly the same, so they're isosceles. For triangle B, three of the angles are the same, so it is equilateral, but because at least two of those angles are the same, we also consider it to be isosceles. Scalene does not apply because these are all the same angles, they're not different, and scalene is only when they're all different angles. For triangle C, we have the same sort of thing happen. All three sides are the same, so it is equilateral. But because two of the sides, or at least two of the sides are the same, we also consider it to be isosceles. And for triangle D, we have a 10, a 4, and a 7. They're all different sides, so we consider it to be a scalene triangle.